All right, guys, welcome to this page of the notes, and what we're going to do is we're now going to start to take a look at this process known as algebraic division in order to divide polynomials, or in order to divide by a polynomial that's not a monomial, something bigger than a monomial. But before we jump into the algebraic division, it's modeled after the long division that you guys did in middle school. So let's just review that real quick, just to sort of get us thinking about how that long division process worked, because we're going to use the exact same process to do algebraic division. Same process as what you did in long division back in middle school. So remember, we did long division anytime you were given a problem where you had to do division and you didn't have a calculator, or we were working with something that was not part of the set of multiples that we had you guys memorize. For example, 513 divided by 2, right? Not one of the multiples that we made you guys memorize. So certainly long division will work, and this will be the one that we're going to do. Couple of terms that you're going to want to remember. I'm going to use these terms throughout the rest of this set of notes, and actually pretty much for the rest of the chapter. So the dividend is the numerator. Dividend is the numerator. That's this guy right up here. That'll be your dividend. Remember, the dividend is what goes under the long division symbol. All right, the numerator goes under the long division symbol. The divisor is going to be your denominator, that guy right there. The divisor is what goes on the outside of the long division symbol. And then your answer, right? Your final answer is what we call the quotient, all right? It is the result of doing the long division, and that's going to be what this whole thing is equal to. Whatever this answer is going to be your quotient, which of course is what's going to be above the long division symbol. Now, one more thing to quickly point out here before we jump into how this actually works. Remember, it is a three-step process for doing long division. The first thing you're going to do is divide, then multiply, subtract the product, and then bring down the next term. You then go back to the beginning and repeat until nothing left to bring down. Right? Once you run out of things to bring down, the process has reached its conclusion and you're done doing long division, right? So you will continue to repeat these 4 steps: divide, multiply, subtract the product, bring down, until you run out of things to bring down. Once you've brought down that last term, the long division process is over. So here's the way it works. Remember, the example problem I had set up for you guys was 513 divided by 2. And again, I apologize. For some reason, when I was writing this equation, I used a radical sign. That is a square root symbol. Please, I am not taking the square root of 513. It should be that long division symbol. I apologize about that. So we're doing long division. 513, my dividend goes under the long division symbol. My divisor, which is 2, goes on the outside. And here's the way it works. What you need to do is we're going to take 5, right? And we need to figure out how many times does 2 go into 5. Well, 2 goes into 5 2 times. So that's the number that goes up top, right? So that is the divide part. How many times does 2 go into 5? It goes in twice. 2 goes up in top. This is my quotient, right? This guy up here is going to be my answer. 2 times 2, that's the multiply, step 2. Actually, here, let me slide down a little bit so you can see my steps. There we go. I do multiply next. 2 times 2 is 4. I then subtract the products, right? So I put a minus sign here, and 5 minus 4 is 1. Last step, bring down, so that 1 comes down. I now have 11, and I repeat the process. How many times does 2 go into 11? Well, 2 will go into 11 5 times, right? Because 2 times 5 is 10. So 5 times, that 5 goes up in my quotient. Then I go to multiply. 5 times 2 is 10. Then I go to subtract. 11 minus 10 is 1. Bring down, right? I'm going through those 4 steps in order until I run out of things to bring down. So I brought down the 3. That's the last thing to bring down. So after this, my process is over. 13. How many times does 2 go into 13? Well, that would be 6 times. That would be 6 times. So that goes in my quotient. 6 times 2 is 12. 13 minus 12 is 1. And again, the way this works is this little guy right here is what we call our remainder. It's what's left over after you have completed the division process. What this means is that 513 is not evenly divisible by 2. You can divide 513 by 2, but you're going to wind up with a little bit left over. Well, what's the little bit left over? In this case, it's a 1. You have 1 left over. Now, the way that this works, you can check your answers. And the way that you check your answers is simply this. The dividend, right, your numerator, is going to be equal to the divisor multiplied by the quotient plus the remainder. Here's the way it works. 513 is equal to my divisor, my denominator, which was 2, and my quotient, which was 256, right? That was the answer I got up here at the top, right? This is my quotient, my answer. Sorry, hold up a second. I forget how to spell Q-T-I-E-N-T, yeah. This is my quotient. My dividend, divisor, my quotient, and then my remainder down here. So what I've got then is this, 2 times my quotient, 256, and then I have to add my remainder, and all that should be equal to 513. So again, what we're going to do is we're going to take that process, that exact same process, and by the process, what I mean is those 4 steps, right? Divide, multiply, subtract the products, and bring down, right? We're going to repeat that process over and over for polynomials, for dividing polynomials until I run out of things to bring down. Now, I've already worked through an example problem here that I've color coordinated to kind of show you the process, but again, I don't like working through problems that I've already solved for you because we don't really learn anything that way. I just wanted to show you another one that, where it's set up for you and kind of color coordinated. But I do want to point this out before we jump to our next problem, and it is simply this. When you divide polynomials, polynomials need to be in descending order, okay? That means that the highest power comes first and then in descending order of power. However, when it comes to doing the long division, when it comes to doing the algebraic division, you're going to make your life much easier if you use placeholders. Here's what I mean by placeholders. If you have, for example, let's just do x squared plus 6x minus 3. Right? Please notice that this is in decreasing order of power. 2, which is my largest power, comes first. Then I have an x to the first, so 2, 1. And then I don't have an any x, right? That would be an x to the 0 power, so 2, 1, 0. 2, 1, 0. Everybody is there. By everybody, what I mean is I have a second power, a first power, and a 0 power. Starting at the second power, every power is there all the way to 0. But what about this one? Well, this polynomial is in descending order. X to the 4th is the highest power, x squared is the next highest power, and x to the 0 is the smallest power. But not every power is represented, right? Starting at the 4th power, I go from 4 to 2 to 0. Who's missing? Well, I'm actually missing 2 of them. I'm missing an x to the 3rd, which would go right in here, and I'm missing an x to the 1st, which would go right in here. When I say up here in the directions that you're going to want to use a placeholder with a coefficient of 0, Here's what I mean. This is just going to make your life so much easier when it comes to algebraic division. What you're going to want to do is rewrite this guy as 4x to the fourth, because that's my highest power. But then I'm missing an x cubed. So we're going to add a 0x cubed, right? Because that's the next power, but it's not there. Now, here's why I haven't changed the problem at all. What is 0 times anything? Well, yeah, 0 times anything is 0, and this term would just go away. Get me right back to what I originally had. So 4, 3. I was given something to the second power, so I'll keep it, 2x squared. I don't have anything to the first power, so I'm going to use another placeholder. But I'm going to use a 0 so that it doesn't change my problem. Plus 0x. Now I have an x to the first power, but because it's multiplied by 0, 0 times anything is 0, that term would just simply drop out, it would go away, and I get right back to what I originally had. 4, 3, 2, 1, and then my 4, which would be the x to the 0 power. 4, 3, 2, 1, 0. I now have every power of x represented in my polynomial, starting with my highest power, in descending order, right? 4, 3, 2, 1, 0. And these two are simply placeholders, right? Because they're going to drop out. I get right back to what I originally had, so I haven't changed my problem at all. But what it's going to do when doing long division is it's going to allow you to line everything up nice and neat. And you'll see here in a second how that's going to really make your life a whole lot easier. So again, when it comes to the placeholders, whatever the largest power of x you're given in the problem, right? Whatever the largest power is that you're given, just make sure that every power in descending order is represented, and if you're missing anybody, use a placeholder to account for that spot or that power of x. You'll just use a coefficient of 0, because then it doesn't change the problem at all. So what we'll do, head over to the next page of the notes. We'll go ahead and try algebraic division for polynomials, and I'll meet you over there.